ask. Any special questions? Any particular issues you have? Okay, hearing none, I will introduce the topic for today. And for your information, the session is being recorded. All right, so today we're going to talk about basic concepts of probability. And we'll try to provide some kind of example. Okay, so basic concepts of probability. Okay. Now, you ask the question in, what is probability about? This is the very foundation of statistical analysis, but also in nature, and probability simply addresses the fact that in nature, nothing is certain except the passage of time. All right, that is certain, except the sun will be up there. You may or may not see it. If there are clouds, you wouldn't see it. But then, would there be clouds? Okay. Out of 10 days, there are 2 days when we see clouds, and on the average, it's 2 days. We look at that over 100 years. During every week, sometimes there are 2 days, sometimes there are 3 days, sometimes there is 1 day, sometimes there is 0. But when you look at the average, you see that there are 2 out of 10 days that you will see clouds cover the sun, and so you will not see the sun, but it is there. So we ask ourselves, what is the probability that there will be cloud that will cover the sunlight? All right, nothing is certain. All right, so this is what we will talk about today. Now, probability by definition is the chance that an event will occur. What is an event? Anything is an event. You wake up in the morning, that's an event. You decide to eat rice instead of beans, that's an event, okay? So you come to school without any issues, and you get public transportation easily. Well, that's an event, okay? And so forth and so on. Anything that happens in nature is an event. But the point is, we do not have, nothing is certain to happen. And so if anything that is certain to happen, then the probability of occurrence of that event is 1. Okay, so let us then look at a simple example of probability. And we're going to look at simple discrete probability. There are 2 ways you can talk about probability. You can look at discrete probability, and then you can look at continuous probability. For this class, we'll be looking strictly at discrete probability. And so, on discrete probability, you're looking at discrete events. For example, if you travel on any block of living space, any block in the city, you can see 3 potholes, or you can see 4 potholes, or you can see 5 potholes. But there cannot be anything like 4.5 potholes, because we just count the potholes as discrete events. The discrete event, if you look at discrete events, then there is no event in between any 2 numbers. For example, there are 5 potholes or 6 potholes. You cannot have 6.5 potholes, and you cannot have 6.000000001 potholes. It's either a pothole or there's no pothole. So those kinds of events are discrete, okay? Where there is no value in between any 2 values, all right? You see, for for example, a goat, a cow, a horse, a chicken. Okay, and you can give them values. Horse is 1, chicken is 2, goat is 3. And there is no value between 2, there is no other value between 2 and 3. So those are discrete events. Okay, all right. So let's now put up what we can use to illustrate discrete events or discrete probabilities. I'm going to use a whiteboard. I'm going to just make this easy so we can move on to illustrations. All right. Just give me a minute. Make this simple. Now, let us say that there's an event E. Let's call that event E. And the events have values of 1, 2, 3, 4. Okay. And the number of occurrences of the event, and we'll call that the frequency of the occurrence of the event. Okay. And here F is frequency. How often does this event occur? Okay. How often does this event occur? And I'm going to just use plain word, but I'm trying to make this as natural as possible. Okay. So F refers to the frequency of the occurrence of event 1. It rained 1 day in a week. It rained 2 days in a week. It rained 3 days in a week. It rained 4 days in a week. And so 10, 20, 30, and 40. Things do not always happen that way. Now, you can use this frequency and ask yourself, what is the relative frequency? And that relative frequency is what eventually we'll call a probability. All right? And so, how many occurrences did we observe? Okay? How many occurrences did we observe? Okay, we observed 100 occurrences. Okay, so we observed 100 occurrences altogether. And so the relative frequency relative to other occurrences. And so relative meaning that 10 out of 100 times we observe the event 1. And so we have 10 divided by 100, okay? So 10 divided by 100 okay? And so the event 2 occurred 20 divided by 100, and event 3 occurred 30 divided by 100, and event 4 occurred relatively 40 over 100. So what we have then is what we call a relative frequency distribution. So this relative frequency distribution, if you now calculate that for each event, we have what now called a probability distribution. Okay. And this is the probability distribution, the probability of each event. Have the probability of E, or the probability of each event. So each event has a probability of occurrence. This is 0.10 or 10%. And this is 20%. And that is 30%. And that is 40%. All right. And if you add it all, you would have a total of 100%. All right. Now, so I'm going to take this off and put up another example so that you can see that probabilities and events do not occur in this very fine form. They don't occur in this very easy form. They don't present themselves in very easy form like that. Okay. So let's take another example. Now, let's think about the number of vehicles that pass an intersection during a period of 1 hour. Okay, number of vehicles that pass an intersection, and we can call them V. Okay, in an hour, 10 vehicles. Another day, we observe 25 vehicles. And another day, we observe 15 vehicles. Okay, or let us say we have observed, not another day, take that back. We have observed 10 vehicles, we have observed 25, and we have observed 15. Okay, so the frequency of occurrence of these numbers of vehicles. So how many observations, how many different numbers of vehicles passed? Okay, so we have, sorry, those are the events, not the numbers. And so here we have observed this 100 times. 100 times we observed 10 vehicles. Say 400 times we observed 25 vehicles. And 500 times, or let us say 250 times, we have observed 15 vehicles. Okay. So what is the relative frequency? And the relative frequency, which is the probability here, how many observations have we made? We've made 500, we made 750 observations. So we're going to use 750 as the total number of observations of vehicles here. Okay. Okay, so the relative frequency then will be 100 divided by 750. Okay. 100 divided by 750. And what is that? Okay. And we're going to use this same formula. And so, and I'm going to just do that one, and then I'm going to set up the probability distribution. Okay, that's 0.133. So that is 13.33%. And 400 over 750 will be 53.3%. And then 250 over 750 will be 33.4%. So you can see we are using essentially the same formula to calculate these probabilities. Okay, so these are the probability of V. And I'm trying to vary this so that we know that there can be variations in the presentation and the representation of events. Okay, it doesn't have to be E. It will be the number of chickens. It can be the number of potholes. So that's essentially what we mean by probability. What is the probability that 10 vehicles will pass through this intersection is 13.3%. What is the probability that 25 vehicles will pass? It will be 53.3%. So let me pull up one of your homework assignments, and then we use that to illustrate this some more. Okay, I'm going to pull up one of your assignments. Okay, are you seeing my screen?
Yes.
Yeah, I see it. I see it.
Okay, so this is an example here, all right, of a discrete probability distribution, and the events that we see here do not have to always occur in exactly that same way, okay? But it's an illustration, okay? Now, we see, for example, that somebody, John, is going to sell hot dogs in a stand, okay? And we look at the number of hot dogs that could be sold based on experience and experimentation. Okay? And experiences are experimentations in nature. They occur naturally. Or you can actually conduct a specific experiment to find out what's going to happen. But now, John, based on experience, or somebody based on experience, has provided the information there. You could sell 100, 150, 200, 250, 300, 350, or 400, okay? These are based on experiences. So what is the probability that John would sell 100 hot dogs? And the probability is 5%. What is the probability of selling 150? Probability is 6%. What is the probability of selling 200? The probability is 10%. And when you add up all the probabilities, you will see that the sum of the probabilities is 100%, or 1, okay? So now the sum of all probabilities must always be 1. The sum of the probabilities of any set of events that you put together are what we call mutually exclusive events and collectively exhaustive. That is to say that if you sell 150 hot dogs, you cannot have sold 100. You sold 150. And so you cannot say that you sold 100 hot dogs and you also sold 150. It can either be 100 or 150. So those two sets of events are mutually exclusive. When you put together, when you consider all the possible number of hot dogs that can be sold, between 100 and 400, those events are collectively exhaustive. That is, you cannot sell less than 100 and you cannot sell more than 400. Everything that will happen between 100 and 400. So those events are collectively exhaustive, okay? There can be no other events. So this is what we mean. Now, you then ask yourself in this kind of a problem, you ask yourself, well, if you have this information, say, how many sausages should John expect to sell? Now, we use probability distributions to calculate what we call expected values. We use probability distributions to calculate what we call expected values. That is to say, it is not certain that you're going to sell only 100. It is equally not certain that you're going to sell up to 400. The probability that you will sell 400 is 0.04. And the probability that you sell 250 is 0.20, or 20%. And so, but you can use this information to calculate what is called an expected value. Now, an expected value is, plainly speaking, in plain English, is an average, okay? An expected value is an average. It's another way of saying an average where you have uncertainties, okay? And in this case, there's an uncertainty. The uncertainty here is that you don't know how many hot dogs you are going to be able to sell. However, based on experience, people have sold between 100 and 400 hot dogs in that particular situation, okay? In practice, based on experience. It could be anything in between 100 and 400. So you ask yourself, if I'm going to undertake this venture, how many hot dogs should I expect to sell? Okay, so let us see how we use probability distributions to calculate how many hot dogs we can sell. So I'm going to copy this. I'm going to stop share this. Excuse me, I'm having some technical issues here. Just a minute. All right, so I'm going to share my, can you see my screen now?
Yes, we can, Professor.
Okay, so now we're going to use this to calculate what we call expected values. So we use this to calculate what we call expected values. And as I said, an expected value is simply another way of saying average. Okay. So expected value is the expectation of sales, or it can just be the expectation of X is equal to the sum, and we use the sum of X, each value that can occur, times the expectation, the probability of X. Okay. The sum of X times the probability of X. So we see here, for example, that you can sell 100. And so you take 100 S times probability of X, which is times 5. So I'm going to okay. So X times the probability of X, or you can say S, let us use S since we're talking about sales, okay, times the probability of S, Okay, so 100 times 0.05 is what? Can somebody tell me 100 times 0.05?
5.
5. So 150 times 0.06 is what?
9.
Thank you. Okay. And 200 times the probability of 200 is what?
20.
20. We can keep going that way. 250 times the probability of 250 is
50.
what?
50.
50. Thank you very much. And so that is 75. And that is 105. Am I correct?
Yes.
Okay. And that is what? 16?
16, yes.
Okay. And so the sum of all of this, the sum of S times the probability of S, okay? The sum, I'm going to just okay, so here, the sum of X times P of S is equal to what? Okay, so if you add here S times P of S, which is, what is the sum of all of this? Can somebody give me the number?
280.
280. So here you can say then that John is expected to sell 280 hot dogs. That is the expectation. Now remember, there's nothing that says he's going to sell exactly 280 hot dogs. This should be his expectation. And as a business person, they're going to use that expectation to say, am I going to take the chance, depending on the cost of hot dogs and the price at which they will sell hot dogs? Am I going to take that chance? Should I buy 300 hot dogs or should I buy 250 hot dogs? That is the question as a business person. And this is what businesses do every day. This is what a venture capitalist will calculate. What is the expected outcome of getting into this? What is the expected number of hot dogs that I can sell? And therefore, should I buy 250 or should I buy 300? Now, remember, you can decide to buy 350. But the point is that based on the price and the cost, price at which you can sell, the cost at which you can buy, if you buy 350, chances are higher that you're going to make a loss because you may not be able to sell that many. But chances are also quite there, quite real, that you can make a big profit because you bought a lot and people also bought a lot of your hot dogs. Okay, there's also the possibility you're going to sell only 100. That means you're going to make a big loss. All right. Now, or you miss an opportunity for a bigger profit. You can make a loss, or you miss an opportunity for making a bigger profit. So so probability distributions provide you a basis for deciding what chance you're going to take. Okay, so now I will then pull up another thing that we do using probabilities. So I'm going to stop share this. All right. And pull up another example of what we do. Now, what we have here in number 3 is, in number 2 is another application of a probability distribution, okay? You invest money and you say, what is the probable cash flow? So the probable cash flow, you can get 80,000, you can get 120,000, you can get 150,000. This is how much you're going to be able to earn in revenues. And so you ask yourself, what is the expected value from this cash flow? Okay, that is what is your expected cash flow. You don't know whether it will be 80,000, you don't know whether it will be 120,000, you don't know whether it will be 150,000, but you have probabilities based on experience. 25% of the time, the cash flow from this kind of investment is 80,000. 65% of the time, it is 120,000. And 10% of the time, it is 150,000. And so what is your expected cash flow? You can also use probability distributions to make comparisons. You have 2 kinds of investments here. Investment number A and investment B. And each one has its own probability. If you invest in A, then the probability of 10,000 is 15%. The probability of 30,000 is 20%, and so forth and so on. But if it is in B, there are different kinds of probabilities based on experience. These are applications that we use in business, applications in business, and you can use those probabilities to ask yourself, what is the probable profit that you can make out of investing in A or investing in B? Okay, so these are your kinds of homework assignments. But essentially what I have done is to explain to you how to calculate expectations. And then those expectations are what we use as information to make business decisions. So on that note, does anybody have any special questions based on what we just discussed? Hello? Okay.
Hi, Dr. Agvi. Yeah, I'm just
No, I have
just
no
looking.
questions.
Okay, go ahead, Alex or Van Axelen. Van Axelen.
Yeah, thanks. Yeah, just looking at the question that we were looking about the hot dog stand.
Okay. Mm-hmm.
So I see that, we have this probability table,
Mm-hmm.
but I'm not really sure how this business owner's fixed costs and variable costs factor into the mathematics.
Okay. All right. Let us now get into that. I am very glad that somebody raised the question. So the question is, you expect to sell 280 hot dogs. You have a decision. The decision is, should you buy 250 or should you buy 280? What you do then is you calculate the profit. What is the profit if you bought 250? What is the profit if you bought 280? I mean, if you bought 300, okay? So let's pull out that problem again, okay? And okay, so this is the problem, all right? Okay, I see the question you're asking. I see the question you're asking. But Your expectation is 280. Now you are a prudent business person, okay? Now you could decide, okay, if my expectation is 280, I'm gonna buy 200. If I sell all 200, that means I miss an opportunity to sell 80 more. You understand that?
Yeah.
Very good. Now, if you bought 300, there's a possibility you're going to have to lose on 20 hot dogs. If you buy 350, you're going to, there's a possibility that 70 hot dogs would be wasted. Does that make sense?
Yeah.
Very good. So, now, how does variable and fixed costs come in? You are going to buy a concession. You're going to get into the stadium to sell these hot dogs. Somebody's going to ask you to pay a fee of $100 before they let you get into the stadium to sell your hot dogs. Am I still making sense?
Mm-hmm. Yep.
Good. So the $100 fee that you pay, even if you sell 0 hot dog, that's on you.
Mm-hmm.
So that's a fixed cost, right?
Mm-hmm.
If you bought 400 hot dogs and you sell all the 400 hot dogs, they're not going to make you pay more than $100. You've already paid the concession fee. They collected the $100. That's it. They cannot say, hey, wait a minute, you made a big profit here. Come give us some more money. Is that making sense?
Yep.
Very good. So that $100 is a fixed cost. So let's go to the problem then. Let me do another share. Okay, so here they say, John has to pay a concession fee of $200 to receive a permit. Sausages can be bought for $2 each. Okay,
Mm-hmm.
so that is a variable cost. Each sausage you buy will cost you $2, right?
Mm-hmm. Yes.
Okay. And so that is a variable cost. But you can sell the sausages for $3.50 each, right?
Mm-hmm.
Okay. Now, sausages can only be purchased in batches of 50. So you can buy 250 or you can buy 300. If you buy 250, your expectation is 280. That's a possibility, only a possibility that you miss the opportunity to sell an extra 30. But it's also possible that if you bought 250, you sell only 100, so you lose money. Okay? All right. So how do variable costs come in? Okay? So suppose you bought 250 hot dogs. If you bought 250 hot dogs, this is what's going to happen. I'm going to stop share. Okay, so let us see if you bought 250 hot dogs, what's going to happen? Your revenue will be $3.50 times 250 hot dogs. Am I correct?
Yep.
What's $3.50 times 250? Give me the number.
$8.75.
$8.75. Okay. How much? What is your total variable cost? Total variable cost meaning, given that you bought 250 hot dogs, the total variable cost will be equal to what?
$2 times 250.
times 250. And what is that?
$500.
500. All right. So what is your profit?
Revenue minus cost. So 250.
It's 75 minus.
Oh.
Minus what?
500.
Minus what? Minus what else? Jamelia. Minus what else? Alexander. Minus what else? Your profit.
Oh, the fixed cost. The
Yes,
$200 fixed cost.
that's correct.
Okay.
Because you paid to get into the stadium.
Right, right.
And what then is your profit?
175.
175. Okay. So now, as a business person, what would you do? You say, okay, if I buy 250 hot dogs, that's possibility I will make 175. If I buy 300 hot dogs, you use the same method to calculate your profit and say, oh, so which one is better? Should I buy 250 or should I buy 300? Now, you can also decide as a business person to buy 400 and take your chances. That is a probabilistic calculation. Take your chances. If you buy 400, let us say you buy 400. Right? Okay. Now, the point of the matter is, if you buy 400, what is the possibility of profit? So let us say possible profit if all 400 are sold. All right. Revenue equal to 3.5 times 400. What is that? 1,400?
1,400.
Thank you. Okay. And what is the total variable cost? Two times 400, am I correct? It was 800. Okay. And so your potential profit, potential now, potential, 1,400 minus 800 minus 200.
400.
It was 400. Okay. What if only 280? Now remember that is your expectation. What if only 280 are sold? That is always what you need to consider as a business person. What is the chance? Your expectation is 280. So your revenue will be 280 times 3.5. Somebody give me that. What is 280 times 3.5?
980.
So what?
980.
980. Your total variable cost, I'm going to call it TVC, will be 2 times 400, remember. And how much is that? That's 800, am I correct?
100, yes.
Okay. So your profit will be 800, sorry, 980 minus 800 minus 200.
-20.
That will be what? Minus 20?
Yes.
Good. Now, the whole idea here is that you are saying to yourself, my expectation, the expectation is 280. Realistic expectation based on this experience. What if I bought 400 hot dogs with the expectation of making this big profit of 400? What if only 280 are sold? What if? What if? That means there's a potential loss of 20. So as a business person, you're going to say to yourself, should I take this chance? Or should I just stay within a comfort zone? You know, there are people who are risk takers. There are people who are gamblers. There are also people who are risk averse, right? They are risk averse. The average person is risk averse. That is, the average person tries to minimize risk. But there are also people who are not average in everything that we do. And so they are risk takers. I say, I'm going to take a chance that I'm going to make 400. But if I end up making a loss, too bad. This is what statistical analysis helps you to do. To calculate your risk, your chances, and make a decision based on your personality. Based on your personality. I mean, to tell you personally as a person, I am not a good risk taker. I am naturally risk averse. I always, when I teach statistics, I say to students, you know, people think that statisticians are sorcerers. They are not fortune tellers. We give you information about the risk you're taking, and it's up to you. So I said to people that when I was a kid, way back, many years ago, in the early 60s, or even before the early 60s, and my mother and other people's mothers would give them 2 pennies. That time you can use 2 pennies to do a lot of things, okay? We used to buy 4 bananas for a penny. Now, when I go to a bazaar, some of the kids will gamble with a penny. They'll gamble with a penny and with the chance of winning a soccer ball. And I would not gamble with my penny. I will buy 4 bananas and eat the bananas. I know I eat my bananas. Others will gamble with their penny and they win a soccer ball. So, well, you're not going to play your soccer ball by yourself. So you bring it to the soccer field and we all play. But then some people gamble with their penny and they lose the penny. Some will say, okay, well, too bad, I lost my penny. Others will cry. And they will shed tears, cry that they should have used their penny to buy 4 bananas like me. So, so this is the kind of decision that you're going to be making as a business person. You want to buy your 4 bananas? So you want to stay within a comfort zone, or do you want to gamble? Okay. So now that's, I hope I clarified that question enough. Any other question?
So in order to make this decision and to sort of fill out the expected value for each of these quantities.
Yeah, you have to first of all find out the expected value. What is it that
value.
Yes, that you know the business person is expected to get? What is the expected outcome? And then you make a comparison, you know, because the comparison there is, should you buy 250 or should you buy 300?
Okay.
And
Thank
then say
you.
to yourself, okay, if I don't want to lose money, I'll buy 250. Or if I want to make more money, then I'll buy 300. But you have to be based on a calculation like the one we just did here.
Okay.
All right. Any other question? All right. Hearing none, I take it that this is over. So I thank you all for coming by today. And I'll see you next time.
Thank you.
Good night.